the following sum can be expressed as a minus 1 over b factorial, where a and b are positive integers. What is a plus b? So we have a huge sum here with 2,000 something terms. And when I express this, it's just difference of two terms only, right? So this suggests using telescopic sums, where each term in this sum, when I express as a difference of two terms, so that when we add them, there are cancellations. So let's try. So we want to write 1 over 2 factorial, and then 1 over 3 factorial, 2 over 3 factorial, right? 3 over 4 factorial, etc. So, well, it's not clear from 1 over 2 factorial. Let's move on to the 2 over 3 factorial. So the numerators now are 1 less than the denominator, right? Each of the numerator here. So if we write it as 3 minus 1 here, 4 minus 1 here, etc., what we get is 3 over 3 factorial minus 1 over 3 factorial. And after the cancellation, so the 3 in the numerator here cancels with the last term of 3 factorial. So we are left with 1 over 2 factorial minus 1 over 3 factorial. That's pretty nice. And it continues. It also works here in the next term and all the terms. Even the first term, we can write it as 1 over 1 factorial, which is 1, minus 1 over 2 factorial. And if you write each of the terms like this, then the last term would be 2021 over 2022 factorial. Once again, let's see how this works here, right? So the first terms give us 1 over 2021 factorial, and the second terms, the minus term, gives us 1 over 2022 factorial. If we add these, see the cancellations. So minus, plus, etc. This would cancel with the next plus term, so on and so forth. And the previous minus term would cancel this last plus term. So after all those cancellations, we'll be left with the sum is equal to the only terms that survive are these two, the first plus term and the very last minus term. So it will be 1 minus 1 over 2022 factorial. So A is 1, B is 2022. So the answer is 2023, choice D.